Hey everyone, welcome to this ACT Math review session. Today, we're going to break down key skills and strategies to help you tackle the math section with confidence.
The ACT Math section gives you 60 minutes to answer 60 questions. That means time management is key.
The test covers a range of topics, including pre-algebra, algebra, geometry, and even some trigonometry. Some questions will be quick and straightforward, while others might require a bit more problem solving. But don't worry, I'll walk you through the important concepts, break down sample problems, and give you some tips to make solving them easier. Let's dive in.
All right, let's talk about fractions, decimals, and percentages, 3 different ways of representing the same idea. You're going to see these a lot on the ACT, so being able to move between them quickly is key.
All right, let's dive into fractions, decimals, and percentages. These are just different ways of expressing the same value, and the ACT loves to test how well you can switch between them. First, let's talk about converting between them. A fraction, like 1/2, can also be written as a decimal, 0.5, and as a percentage, 50%. The key is knowing how to move between these forms. To turn a fraction into a decimal, you divide the numerator by the denominator. To get a percentage from a decimal, just multiply by 100. Next, we have operations with fractions, addition, subtraction, multiplication, and division. When adding or subtracting fractions, you need a common denominator, which means adjusting the fractions so they have the same bottom number. Multiplication is simpler. You just multiply straight across. And for division, remember to keep change flip. Keep the first fraction, change the division sign to multiplication, and flip the second fraction. Percentages are also a big part of the ACT. A common type of question asks you to find a percentage of a number. The best trick? Convert the percentage into a decimal and multiply. Let's try an example. What is 30% of 250? We start by converting 30% into a decimal. That's 0.30. Then we multiply 0.30 times 250 equals 75. So the correct answer is C, 75. This method works for any percentage problem. Just remember, percentage problems almost always involve multiplication, and keeping things in decimal form makes calculations easier.
Now, let's talk about one of the most important rules in math, order of operations. This is what tells us which calculations to do first in a math problem. You may have heard of PEMDAS, which stands for parentheses, exponents, MD, multiplication and division from left to right, AS, addition and subtraction from left to right. This means we always start with parentheses first. Anything inside parentheses has to be simplified before moving on. Next, we take care of exponents, things like squared numbers or cube roots. Then we handle multiplication and division, but here's something important. Multiplication and division are done in the order they appear from left to right, not necessarily multiplication first. The same goes for addition and subtraction. So let's go over a strategy. 1. Work inside parentheses first, if there are any. 2. Simplify exponents before moving on to multiplication and division. 3. Follow the left to right rule when dealing with multiplication, division, addition, and subtraction. This order keeps everything structured, so we all get the same correct answer. Let's try an example together. So, let's break this down step by step with an example. What is the value of 3 plus 6 times 5 plus 4 divided by 3? A. 15. B. 21. C. 19. D. 27. Alright, step 1. Start with parentheses. Inside the parentheses, we have 5 plus 4, which equals 9. So now our expression looks like this. 3 plus 6 times 9 divided by 3. Next, we handle multiplication and division from left to right. First, we multiply. 6 times 9 is equal to 54. Then we divide. 54 divided by 3 is equal to 18. Now we're left with 3 plus 18. And that gives us 21, so the correct answer is B, 21. A common mistake would be adding 3 plus 6 first, which would give the wrong answer. Always follow the PEMDAS order, and when in doubt, rewrite each step to keep it organized.
Next up, let's talk about exponents and square roots. Exponents are just a shorthand way of multiplying a number by itself multiple times, and the ACT loves testing your understanding of exponent rules. Key rules to remember. 1. Multiplying with the same base, add the exponents. A to the power of m times a to the power of n equals a to the power of m plus n. 2. Power of a power, multiply the exponents. A to the power of m raised to the power of n equals a to the power of m times n. 3. Dividing with the same base, subtract the exponents. A to the power of m divided by a to the power of n equals a to the power of m minus n. 4. Negative exponent, flip the fraction. A to the power of negative n equals 1 over a to the power of n. 5. Common square roots, memorize the basics. The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and the square root of 25 is 5.
Now, let's talk some strategies for solving these type of problems. 1. Break down large exponents into smaller parts. When dealing with large exponents, it can help to simplify the problem by breaking the expression into smaller, easier-to-handle parts. For example, if you have a to the power of 12, you can rewrite it as a to the power of 12 equals a to the power of 6 times a to the power of 6. Breaking down the problem into smaller parts allows you to work with smaller exponents, which can make the math easier to manage. 2. Watch out for negative exponents. Negative exponents might seem tricky at first, but they follow a simple rule. You flip the fraction. For example, a to the power of negative 3 is equivalent to a to the power of negative 3 equals 1 over a to the power of 3. When you come across negative exponents, make sure to flip them, turning them into a fraction where the negative exponent becomes positive in the denominator. Alright class, let's go through this problem step by step. The problem asks us to simplify the expression, the square root of 2 to the 4th power times 3 squared. First, let's evaluate the exponents inside the square root. 2 to the 4th power means 2 multiplied by itself 4 times. 2 times 2 times 2 times 2, which equals 16. 3 squared means 3 times 3, which equals 9. Now that we have evaluated the exponents, we rewrite the expression as the square root of 16 times 9. Next, let's multiply 16 and 9 together. 16 times 9 equals 144. Now our expression is simply the square root of 144. Finally, let's find the square root of 144. Since 12 times 12 equals 144, we know that the square root of 144 is 12. So our final answer is 12. The correct choice is option B, 12. A quick tip, the ACT often includes negative exponents in answer choices to trick you, so be careful. If you see a negative exponent, rewrite it as a fraction before simplifying.
Now let's move on to solving linear equations. These problems ask you to find the value of x that makes the equation true. What to remember? You'll often need to use the distributive property or combine like terms before solving. The goal is to isolate x on one side of the equation. Always check your answer by plugging it back in. When solving algebraic equations, we want to follow a clear strategy to find the correct answer. There are 2 key steps to keep in mind. First, we isolate the variable step by step, and second, we check our answer by plugging it back into the original equation. Let's break this down. Step 1. Isolate the variable. Our goal is to get the variable by itself on one side of the equation. To do this, we perform inverse operations. If something is added to the variable, we subtract it. If something is multiplied by the variable, we divide. We continue this process step by step until the variable is alone. Step 2. Check your answer. Once we find a value for the variable, we substitute it back into the original equation. If both sides of the equation are equal after substitution, then our answer is correct.
Sample problem. Solve for x. 3x minus 7 equals 2x plus 5. A. 7. B. 8. C. 9. D. 12. Step-by-step solution. Step 1. Isolate the variable. We want to get all x terms on one side. Subtract 2x from both sides. 3x minus 2x minus 7 equals 5. X minus 7 is equal to 5. Step 2. Solve for x. Add 7 to both sides. X equals 12. Step 3. Check the answer. Substituting x equals 12 into the original equation. 3, 12, minus 7 equals 2, 12, plus 5. 36 minus 7 equals 24 plus 5. 29 equals 29 true. Final answer. X equals 12, so the correct answer is D, 12. A common mistake is forgetting to switch signs when moving terms across the equal sign. Just remember, whatever you do to one side, you must do to the other.
All right, let's talk about quadratics. These show up in the form of ax squared plus bx plus c equals 0. Sometimes you can factor them, and other times you'll need to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Factoring is the easiest way to solve a quadratic equation when possible. Here's how you do it. 1. Identify a, b, and c. The quadratic equation is written in the form ax 2 plus bx plus c equals 0r. A is the coefficient in front of x2. B is the coefficient in front of x. C is the constant, the number with no variable. 2. Find two numbers that multiply to c and add to b. Look for two numbers that multiply to c and add to b. Once you find them, rewrite the middle term, bx, as the sum of these two numbers. Then, factor by grouping.
Sample problem. Factor. X squared minus 7x plus 12. Step-by-step solution. 1. Find two numbers that multiply to 12 and add to minus 7. Oh, those numbers are minus 3 and minus 4. 2. Rewrite the expression as x minus 3, x minus 4. So the correct answer is x3, x4. Asterisk, if you're not sure, you can always check by expanding. Open parentheses x minus 3 times x minus 4 equals x squared minus 4x minus 3x plus 12, which simplifies to x squared minus 7x plus 12. Perfect match.
All right, so functions are just a fancy way of saying plug a number in, get a number out. The most common form you'll see is f(x) equals mx plus b, which is a linear function. But don't forget, some graphs are quadratic, parabolas, or exponential, curves that grow fast. Strategy. If it's a linear function, find the slope, m, and y-intercept, b, right away. Pay attention to shifts. Does the graph move up, down, left, or right? If a function is squared, like x superscript 2, it's probably quadratic. If it has an exponent, like 2 to the power of x, it's exponential.
Sample problem. If f(x) equals 2x plus 3, what is f for? A, 8.
B, 9.
C, 10. D, 11. Solution. Just plug in 4 for x. f(4) equals 2, 4, plus 3 is equal to 8 plus 3 is equal to 11. Answer. D, 11.
Ever wonder how far apart 2 points are on a coordinate plane? That's where the distance formula comes in. D equals the square root of the quantity, x sub 2 minus x sub 1, squared plus y sub 2 minus y sub 1 squared. And if you need the middle point between two locations, use the midpoint formula. M equals the coordinates of the midpoint, which are the quantity, x sub 2 minus x sub 1, squared divided by 2, and the quantity, y sub 2 minus y sub 1, squared divided by 2. Strategy. When using the distance formula, square your differences first, then add, then take the square root. The midpoint formula is just averaging the x's and the y's.
Find the distance between 1, 2, and 4, 6.
A, 4.
B, 5.
C, 6.
D, square root 25. The question asks us to find the distance between the points 1, 2, and 4, 6. First, let's recall the distance formula, which helps us find the straight line distance between 2 points on a coordinate plane. The formula is D equals the square root of Open parenthesis x sub 2 minus x sub 1 close parenthesis squared.
Plus.
Open parenthesis y sub 2 minus y sub 1 close parenthesis squared. Now let's identify what each part means. The coordinates we were given are x sub 1 is 1 and y sub 1 is 2. X sub 2 is 4 and y sub 2 is 6. Let's plug these into our formula step by step. Step 2. Subtract the coordinates. Subtract the x values. We take x sub 2 minus x sub 1, so that's for minus 1, which equals 3. Subtract the y values. Next, we take y sub 2 minus y sub 1, so that's 6 minus 2, which equals 4. Now we square the result. 3 squared is 9. And we square that result. 4 squared is 16. Step 3. Add the squared values. Now, we add the two squared values together. 9 plus 16 equals 25. Step 4. Take the square root. Finally, we take the square root of 25, which is 5. So our final answer is 5. Looking at our answer choices, we see that the correct answer is option B, 5. And that's how you use the distance formula step by step.
Triangles pop up everywhere, and knowing a few key rules will make your life easier. The Pythagorean theorem helps with right triangles. A squared plus b squared equals c squared. For angles, remember SHCHDOA. Cosine equals opposite / hypotenuse. Cosine equals adjacent / hypotenuse. Tangent equals opposite / adjacent. Strategy. Special triangles like 30-60-90 and 45-45-90 have set side ratios. Memorize them. If a triangle problem gives you an angle and one side, use trig functions to find the missing side.
Here's a sample problem. A right triangle has a hypotenuse of 10 and one leg of 6. Find the other leg. A, 5. B, 8. C, 10. D, 12. Solution. Use the Pythagorean theorem. 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. B squared equals 64 and b equals 8. Answer. B, 8.
All right, let's wrap it up with some key takeaways to help you crush the ACT math section. Memorize essential formulas. The ACT doesn't give you a formula sheet, so you need to know the important ones, like the quadratic formula, distance formula, SHCHDOA, and area/volume formulas. Manage your time wisely. Don't get stuck on one tricky problem. Skip it and come back later if needed. The first 30 questions tend to be easier, so move quickly to save time for the harder ones at the end. Use process of elimination. If you're stuck, cross out answer choices that don't make sense. Plugging in answer choices, especially on algebra problems, can save you time. Take practice tests. Get used to the pacing and the question styles. Review your mistakes. Learning from them is key. The more you practice, the more confident you'll feel on test day. You got this.